All right, let's get started with part 1 of Lab 4. In this, we're going to be looking at travel time for different seismic waves, including the P wave, which is the first to arrive, the shear wave or S wave, which is the second to arrive, and the surface wave, which is the slowest wave because it's traveling around the outside of the Earth. So the first thing we're going to do is look at the graph on the next page, and we're going to label which one of these is the P wave, which one is the S wave, and which one is the surface wave. And one easy way to do this is to think these lines are saying when these different waves arrive. So we go to any distance at all, let's just say 3,000 here. The first wave to arrive is going to be the fastest wave, so that's going to be the P wave. So you'll just label this as P. And then I'll let you work through the S wave and the surface wave, but obviously the S wave is going to be next, and then the surface wave is going to be the last to arrive. And then it asks you to plot all of these points on a map. So you can see that obviously a place like Darwin, Australia stays the same distance from the epicenter of the earthquake no matter what wave is arriving, but those waves arrive at different times. So the first wave to arrive once again would be the P wave. Let's see if that works out. So at 1500, there should be a P wave at 3.2 seconds. I'm going to go back to my travel time graph. I'm going to add a circle here. And then if I go to 1500, so here's 1000, 1100, 200, 300, 400, 500, 1500 is right here. And it was at 3.2, which would be right around 1, 2, 3. These are each minutes here, 3.2. And let's see if I did that correctly. Darwin is at 1500 and 3.2. So that is the P wave arrival. Let's add the next one at 6. This is going to be the next wave to arrive, which you have labeled. And this is going to happen in 6 seconds. And once again, we can see that this is coming in right around where we would expect it to, at least one of the lines. And then the last one for Darwin is arriving at 6.6. So I'm going to also put that on. And you'll just go ahead and you'll continue through and add all of these points to the map. They should, all of these points should be very close to falling on one of these lines here. And then you'll have your data plotted on a travel time curve.